Welcome to Forecasting Impact, a podcast brought to you by the International Institute of Forecasters. This show brings together experts from academia and industry to discuss a wide range of subjects on forecasting science and practice in business, society, economy, healthcare, and education. Thank you for choosing to spend some time with us today.
Hello, everyone. Welcome to Forecasting Impact. This is Mahdi Abolghasemi, and I'm connecting once again to Forecasting Impact from Brisbane. I'm really glad to be here. Today, we have a guest, Marco, which I will introduce him in a second. And also we have Mariana, a great co-host, connecting from Mexico. Mariana, do you want to say hi?
Yes, hi, it's a pleasure to be here.
Great to have you. And I'm going to introduce our guest before getting started on this. Marco Peixeiro is an applied data scientist at Nixtla, where he works at the intersection of research and practice in time series forecasting. He is the author of the book Time Series Forecasting in Python and the upcoming Time Series Forecasting using Foundational Models. Marco is the maintainer of NeuralForecast, Nixtla's open source library for time series forecasting using deep learning models, and a frequent writer on Medium, where he shares his insights on time series modeling and explainability. Marco, it's great to have you.
Thank you so much. That was quite an introduction. I usually don't introduce myself that way, but that was great.
No, it's great to have you. I know Mariana has been trying to schedule and reschedule this call for a while, and we always wanted to have you, I think, for the first book. And now it almost has stretched to a way that you are going to publish your second book as well. So it's a good timing to talk about both of them.
Absolutely.
And I'm really looking forward to this discussion. You know, as a tradition in Forecasting Impact podcast, we always start our conversation by learning about your journey. Everybody has a journey, and we've realized that there's a lot of randomness in how people are, get into forecasting. So I'm going to start off by this question to see how you got into forecasting, and give us an overview of what you do and where you're up to.
Absolutely. So I got into forecasting really out of curiosity. So I guess I started my career as a data scientist at a very large bank in Canada, working more in traditional machine learning, I would say. So, tabular data, nothing really changing in time, until I started thinking, well, what if my values were changing in time, right? What if it's not just, classification and stuff like that? Because at the bank, just turns out a lot of the work was classification. So I started thinking about it and, realized I don't know how to do that. So started learning time series forecasting, picking up blogs on the internet, online courses. And at the time, it was a bit frustrating for me because everything was in R, and I'm not an R coder at all. I don't know how to write in R. I'm a Python programmer. So I had to translate the code myself to Python because, again, all of this was before the LLMs and everything, right? So much more manual work had to be done. So yeah, but I guess all that effort paid off because from this, I would say, frustration of not having access to Python code for forecasting, I wrote my first book, so Time Series Forecasting in Python, did an online course as well. Everything was very well received, started blogging about it, people were liking it, until, I stumbled upon the Nixtlaverse, and I really wished I knew about it before. But yeah, stumbled upon the Nixtlaverse, found it amazing, and then, reached out to the team, wondered, is there any way I can work with the best? Because honestly, from their work, everything was so smooth, so fast. And now here I am at Nixtla, building also in the Nixtlaverse, working on TimeGPT and all this great stuff. So yeah, that has been my journey so far.
Thank you, Marco. You're currently an applied data scientist at Nixtla. You're working at the intersection of research and practice. And can you tell us how does that work? I mean, we're connecting research ideas with real-world forecasting applications?
Yeah, so I find it thrilling, of course. I'm really passionate about my day-to-day job, and I think it's really amazing, this idea of we get to translate all those research papers into models, and models that are easy to use for everyone. So really, lowering the barrier of using state-of-the-art models for everyone, or at least for programmers. I think this is super special, super useful. And on top of it, there's a very nice layer of engineering, I would say, to keep everything, everything really fast, everything simple, everything smooth as well, to work with all kinds of features, loss functions, etc. That's also something that is very, very motivating. And, just a step beyond of, this model works, but it's in a sense like a very academic implementation. Now we're bringing this back, to like highly optimized version. So yeah, it's great. It's tough, but it's really, really fulfilling.
Yeah, I'm sure that production phase is a big thing that is missing in academia. And I know it has got all its own challenges. It's just the start of the way. It's not like we did the model, we are done. No, it's actually the start of the paths that we are going through. There's a range of topics that we want to tackle today, but one of the things that I'm also really interested to know more about is the explainability. And that's a topic that you have worked on, and I'm sure our audiences listening to this podcast, some of them are familiar, some of them probably not, but could you give us some simple definition of what it means, explainability in time series context, and what's the importance of it? And then we're going to dive into that a little bit more.
Yeah, absolutely. I mean, I like to start from a more, I guess, traditional machine learning point of view, because I think people are maybe more comfortable with that. So, when you have a regression problem, right? So in machine learning, maybe you want to predict the price of houses, right? And you take features like the number of rooms, the space of the house, or the square footage of the house, and different features. I don't know, is it near the water or not? Stuff like that, right? There is a part of you that wants to know, what is the difference between a house with 3 bedrooms and a house with 5 bedrooms, and how is that difference impacting the price of my house, right? Or why is a house near the water more expensive than a house that it doesn't have a waterfront, right? So this is explainability, right? It's the capability of understanding that this feature, when it moves in a certain direction or when it changes, impacts the model output in a certain way. So same thing for time series forecasting, right? But now we also add the dimension of past values. So it's also, how is the past impacting my future on top of features, right? So, it's not only because it was 20 degrees yesterday, tomorrow is going to be 22 degrees, but it's also because we expect tomorrow to be rainy. How is that going to impact the temperature of tomorrow, right? So that's the entire idea of explainability and how it fits into time series forecasting.
And Marco, I'm sure many listeners are interested in understanding how different variables such as promotions, prices, or holidays affect their forecast. This is something I have to work with every day. And you have implemented explainability methods such as SHAP values across Nixtla's Python libraries. Could you explain to us what SHAP values are and how they help us interpret model behavior?
Sure, of course. I mean, little disclaimer, I am not an expert in SHAP values, okay? So I'll do my best to explain them clearly. But my understanding, basically, SHAP values is derived from game theory. And what it tries to achieve is basically, the model is, in a sense, the game. And so the output of the model is the result of the game. And then each feature is treated as a player. And then with SHAP values, it says, what if a player joins the game or does not join the game? How does that impact the outcome of the game? In this case, a player joining the game means we know the value of a feature. A player not joining the game is we don't know the value of the feature. And then it tries to, give a fair attribution to each player, to each feature, right? In how it impacts the output of a model. And so the way it works, right? So either we know the value of the feature or we don't know the value of the feature, meaning the feature exists or doesn't exist. And then a SHAP value is going to tell us, from that little exercise, how is this feature specifically impacting the models, or is it increasing the prediction or decreasing the prediction, pushing it upwards or downwards, and also the magnitude. So is it pushing it upwards by like 2 or downwards by 2 as well? So this is the general idea of SHAP values.
So maybe it is the question that I want to ask is more relevant to the previous one, but how is that different from features importance?
Yeah, so my understanding is, feature importance is pretty hard to derive from forecasting models. just think about statistical models or even deep learning models, it's very hard to derive that feature importance due to the scale of the data or just the nature of the model itself. So, feature importance, in my experience, mostly comes from decision tree algorithms, right? And so that generally tells you, basically when the tree splits, right? And like how high in the hierarchy is the split occurring. That is going to tell you about feature importance. But feature importance doesn't tell you the magnitude of the change either. So it is important, but you don't know how it is impacting the model. And that changes the question completely, right? So if you want to know, like Mariana was saying, is my promotion increasing my sales or not impacting them or decreasing them? Feature importance is not enough. You need SHAP values or explainability to be able to get that answer.
Yeah. Yeah. And just as a follow-up, what are the challenges that you see in this context for, when it comes to modeling time series forecasting?
Yeah, so the challenge was, and it remains a challenge, it's not very common to see explainability for time series forecasting. So, from statistical models, if we use something like ARIMA or ETS, you could always use the model's parameters and coefficients to get a sense of explainability, but it's not the same. And then in using machine learning models, that's a bit more common simply because, machine learning, when I say machine learning, I mean like, stuff like tree-based methods, KNN regressors, stuff like that. Everything in sklearn basically that has usually explainability built in, so that's usually fine. In deep learning, very hard, not implemented at all. Like Mariana said, this is a work that we've done very recently within NeuralForecast, me and my colleague Olivier. So that remains the main challenge. It's not really well implemented. What you see in the literature, you see very nice theory, but no implementation of it. And again, that's the bridge between academia and actually implementing it. So that was still missing. And again, sometimes, just this assumption that deep learning is just this black box model, very hard to explain and everything. But, now we have the methods to do it. So it was, crossing this line of, no, we have the methods, we can do it. And now we do it also at scale throughout many deep learning architectures.
And Marco, now that you mentioned this bridge between academia and industry, I think that explainability in forecasting is very important, especially when dealing with business stakeholders, as it is a key to building trust in forecasts. And how do you approach communicating this to non-technical stakeholders in a way that makes sense and is reliable?
No, great question. So, the first step for that was definitely implementing the methods, getting the methods, available into the hands of practitioners in forecasting. And now I think it's pretty much self-explanatory in the sense that, like I said, now the SHAP value will tell you already this feature is impacting the output by this magnitude and in this direction. And I think that becomes like really clear for non-technical stakeholders, because now we can say, because of this promotion on this day, the forecast increased by that much. And then because of a discount on this day, it increased by that much. Or because of this feature, now it decreased by that much. And it becomes also then very easy to play with the values of the features. So, usually a discount, a promotion is something you control yourself. So you can say, if I put a 20% discount, how does it impact? What if I change it to 15%? How does it impact? And now you can measure those impacts, with a clear set value. So yeah, I think that's tremendous. But really, we had to get those methods available to everyone to do that.
This is an ongoing work that you will continue in NeuralForecast together with your colleague Oliver Sprangers.
Yes, absolutely. Yeah, we are not done. It is hard. It is tough, but I think it's been very well received by the community. And we're now one of the only library to do it for deep learning. Anyway, to the best of my knowledge. So if I am wrong, anyway, let me know somehow that I am wrong. But yeah, to my knowledge, I think we're the only ones.
Oh, that's awesome. I think it's such an important topic. And this is one of the things that we need to do more research, and we need to have more packages and books to make that a bit easier. And I really appreciate that.
I think that SK Forecast is working on explainability as well. So this is actually something very, very exciting that the community is clearly working on, and is something that the community wants.
Yeah, definitely. Just out of curiosity, again, this is maybe a little bit off topic, but we're talking about explainability. And how do you see the connection between causal models and explainability? If you can shed light on that. I think if that's out of the scope of the conversation, yeah, I'm sorry for asking this, but just wanted to know if you know anything, any
Not at
connections
all.
there.
So again, not an expert in causal machine learning or causal inference. It's something that I've been meaning to get into because it's a different explanation from SHAP values. Because with causal explainable machine learning or causal inference, from what I know at least, you're trying to, how do you say that? You're trying to infer what they call the causal graph in a sense, meaning that you have, a certain aspect that impacts something else, so you know the causal relation exists, and then you have what they call confounders, which is, this can also impact your end result, but it is not related to the initial treatment. And then you have, so all this idea of treatment effects. So you're measuring the average treatment effect, conditional treatment effect. So it is very different from explainability. This was probably a very bad explanation of causal inference. So if anyone expert, in this, I'm very sorry to butcher the subject, but I do think it is very different. And it's also about assessing, is this causal relationship true? Is it holding? What is the impact as well? So yeah, very different. I think it's a much more complete picture of explainability. Explainability, the way we're doing now with SHAP values and everything is nice. It's a good first step, but having really the causal graph and measuring that causality is the next step, I believe.
Yeah, very nice. I like the distinction and the way that you describe it. Thank you very much. Yeah, but the other one that I wanted to ask, because you discussed the neural forecast and then looking after this, how is it like managing this package and this great work that you guys do?
So, I mean, it's fun. First of all, it's fun. That's for sure. Second of all, there's quite a bit of pressure, I would say, in the sense that you're really trying to balance this. We're building features that the community wants. We're trying to please everyone also, but also, about selecting what you're going to work on and what are going to be the next steps. So, sometimes people, they ask for a particular model in NeuralForecast. And we have to make the call. Do we implement that model or not? Thinking about, maintainability. Do we want to maintain this model? Is it actually useful? Is it actually performant, worth including and everything? So, there's quite a bit of work in that. Also thinking how it fits in within all that has already been built, right? So yeah, there's this little challenge as well. And then, many times people come up with new problems that we didn't even think about, or bugs that were very obscure. And so, we get to fix them or implement new features about that and everything. So I think it's really fun, and it's crazy to see that, NeuralForecast, even though it's been built for quite a bit of time now, we still see new bugs, new ideas, new features to implement, new ways of improving the library overall. So yeah, I think it's thrilling, it's challenging, and I really like the community support aspect of it. So people using NeuralForecast, asking questions and everything, answering them, making sure they use it correctly. Yeah, it's very, very, very great and fulfilling.
It's not a trivial task, but it seems to be a lot of fun. And Marco, moving now to your books, you're also
Yes.
the author of two books on time series forecasting. Your first, Time Series Forecasting in Python, helps practitioners learn the fundamentals. And I would like to know who's the primary audience and what was your goal when writing it?
Yeah. The goal, should I say that in a podcast? The goal of this book was actually for me to learn it and really master the subject in a sense, And that has always been my goal when I make courses and blogs and everything. It's my way of learning because I really believe in you've learned a subject when you're able to teach it. So I try to implement that. Basically, I try to live by that. So that was the main goal of the book. And actually the editor reached out to me to write the book. It wasn't my idea to write a book. So the editors reached out to me and asked, "Do you want to write a book on the subject?" I was like, "Sure, why not?" It was COVID, so I couldn't get out of the house, couldn't see friends. So I was like, "Yeah, it's a good time to write a book." So that's how it happened. And the goal for me was really, let's write a book for data scientists, beginners in a sense. They've done some machine learning, but they don't know how to get into time series forecasting. So, your features are changing in time. What do you do with that? So that was the goal of the book. So, write something for them. So they learn the fundamentals using statistical models, also deep learning, in a say more from scratch in a sense. Not that much abstraction, just so they can understand the logic of using deep learning for forecasting. So yeah, of course, everything had to be in Python because again, at that time, it was still the frustration of R for me. So it had to be everything in Python, and that was like one of the, again, at the time, not many books existed about forecasting using Python specifically. So it is something that set the book apart as well.
Okay, that's great. Where do people can get a copy of that book? Is it available online?
Yeah, so on Amazon and also from the editor directly, which is called Manning. So Manning Publications. Yeah, you can get it there or from Amazon. So yeah.
The title is Time Series Forecasting in Python.
Exactly.
Just to
Yes.
reiterate. Okay.
Yes.
Beautiful. And the other book that you have, I know it's upcoming, and I'm looking forward to go through it in details because I've got a copy now, but time series forecasting using foundational models.
Yes.
And this is really timely, good for this book. First of all, I would like to know a little bit more about these foundational models. And I know our listeners also would appreciate to know a little bit about foundation models. What do they mean? Where do they come from? And where are we in this space? And what do you talk about it in your book? So I would appreciate that to discuss more on this interesting topic.
Yes, sure. So let's start with foundation models. Foundation models, I think we're not strangers to foundation models anymore, right? We started seeing them appear in natural language processing, right? So the large language models, ChatGPT came up, everybody was amazed, right? I can write something and it spits back whatever, an answer, true or false, doesn't matter at the time, right? It was crazy. So there was also that in computer vision, but I think that domain is not as mainstream as natural language processing. And then I think it entered time series forecasting, mainly with TimeGPT, or at least at the time is when I read the article of TimeGPT, and I think it is the first foundation model, one of the first at least, to be released. And so the idea of a foundation model is you have this very large model trained on a massive data set. And now, this model, this pre-trained model, can forecast anything that you want. So no need to train a model from scratch anymore. You don't need to do hyperparameter tuning or, gather your data, clean it, do whatever, do feature engineering and all of that. You don't need that anymore. You just take your data that you have, send it to the foundation model, in this case, the foundation forecasting model, right? And then that spits back forecasts and, very, very often those forecasts are very good and even better than those that you can do with your own, what I call data specific models. And that's a pretty big game changer because again, before foundation models, it would be one model per use case in a sense, right? So you have your model to forecast this product and your model to forecast this other product and your model to forecast revenue and so on and so forth, right? So you'd have a bunch of models that you have to maintain, that you have to train in order to forecast everything that you needed. With foundation models, that disappears entirely. You have one model, very big, but now it forecasts everything that you want. Doesn't matter the frequency, the length of the series, right? The number of features, whatever. One model forecasts everything. And so that's a very big thing.
Thanks for the introduction. That's a very good introduction. So do we need to fine tune the model or is it just inferencing whatever data that you have, you give it, and then the model generates a forecast for you.
So you have that option for sure. So that's the main advantage of foundation models. Instead of training them, you can just fine tune them, and fine tuning usually is simpler and also lighter to run than training a massive model. So you're just going to fine tune. So you're going to specialize the model slightly to your use case, to your data set, and that usually gives better performances from those models. But the main advantage stays the same, right? One model, just fine tune it, and then you can just deploy it on everything. So yeah, definitely.
Marco, you have also worked on explainability for these models. What are the main challenges you see when making foundation models explainable?
The main challenge is that they are huge. Is that those models are simply massive. And so it comes back to the methods that we have right now available to explain time series models. Again, we're dependent on methods, related to either gradient computation or SHAP values, basically. And so if you want to use explainers based on gradient computation, then that requires forward and backwards propagation. And so the model has to be in training mode. And so that means that you need to have a lot of memory available. Because again, those models, right, those foundation models, they're trained on multiple GPUs, lots of RAM, right, lots of memory. So if you want to compute explanation, you need to have this hardware available. That's pretty hard. That's not usually the case for everyone. And if you want to if you don't want to use the gradient, that's fine. You can use Shapley values, but then those explainers are very slow, terribly, terribly slow. So you can get explanations, but be ready to wait a good half hour, maybe to get some reasonable explanations. So yeah, that's really the big challenge, and it just becomes from the sheer size of the model. That now our explainers, it's not really scalable for those models anymore.
I would imagine that how difficult would be explainability in this context. I'm not quite sure, the foundational models that we have, Chronos or Time GPT, or the other models that we have, how many parameters they have. We're talking about millions or hundreds of millions or something like that in that scale. So I would imagine it would be a much more challenging problem to this. Do you actually talk about explainability in your book, Time Series Forecasting Using Foundational Models?
No, not there.
Okay.
Because I've done the work on explainability after I started writing the book. The book, at some point I have to stop writing, otherwise my editors are going to be mad at me. So I have to stop describing algorithms and everything. But no, explainability is not a subject that I touch upon, or at least with TimeGPT, turns out we have explainability built in TimeGPT with SHAP values. So I do mention, and I have a code example of how you can explain the impact of your features with SHAP values in TimeGPT. But integrating explainability in other foundation models, that's a work that I started doing now, and that's a bit more involved and not covered in the book.
Yeah.
You already have material for a second edition of that book.
There you go.
Yes.
There you go.
So just to reiterate on that book, I've had a look at it, but what do you cover? Maybe you can tell to our audiences, what do you cover in this time series forecasting using foundational model?
Yeah, sure. So, first chapter, pretty much big overview of foundation models, what is a foundation model, why is it useful. We explore the transformer architecture because still to this day, the transformer is behind most of the foundation models we see, both in natural language processing and in time series forecasting. So I figured let's understand the transformer so then we can focus on something else when we explore the different models. And then I also go through a little exercise of building a foundation model on a very, very small scale, just so that people understand the ideas of pre-training, fine-tuning, transfer learning, stuff like that. So really the core concepts of foundation models. And then the following chapters, we just explore different algorithms, different models that exist. So, TimeGPT, Morai, TimesFM, Chronos, really the big releases at the time. Of course, new models came out since then. I cannot keep the book, I cannot keep adding to the book. Otherwise, it would be 1,000 pages long. So I had to stop at some point. But yeah, we take a look at the biggest, contributions. And, once you know those ones, you can pretty much work with anything afterwards. We also have a little exploration of LLMs for forecasting because, at some point the research was going there. It was like, if an LLM takes a sequence of words to output another sequence of words, shouldn't it be able to also do that with time, right? So a sequence of numbers to another sequence of numbers. So, we take a look at that. Can we turn this forecasting task into a natural language task? So, I developed some methods there. We explore, is it actually good or not? And then, the last chapter is a capstone project. That's always something I like to do. So take everything that we've learned from the book, apply it in a new scenario, but it's really open-ended. I suggest a solution, but the goal is really for the readers to, implement whatever they have learned, do it their own way, and then see, the trade-offs, like this is performant, but is it fast, or this is slow, and so on. The idea is that now they have the tools to test out different models and then choose the best one for their own scenario, because that remains true whether we have foundation models or not. Not a single foundation model will work for every situation. So it's still important that practitioners, data scientists, they know how to evaluate those methods and make the right decision based, on metrics and having a rigorous testing protocol as well.
Very nice. I've had a quick look through the book, and just go get a copy of this book if you want to get to know foundational models. I think it's a really good book. It has nice examples in Python, and it's a best way to get started on this journey.
I think that the book does a very good job of explaining difficult and technical concepts. And that actually leads me to another topic I want to talk with you, Marco. You're also very active on Medium, where you have written several articles explaining how different forecasting models work. And what's the most challenging part of writing these technical articles explaining how the models work?
Yes, great question. It's very tough to answer that question. It all started with the first model I explained in forecasting was NBeats. And I really just, I read the archive paper and I was like, okay, I kind of understand what this is, but honestly, the mathematical equations were like, sometimes like bogging me down a little bit. But I was like, no, I think I understand this, from intuition. And so that's how it started, like, let's try to explain these models like without those complicated equations and just like using intuitions and schematics and stuff like that. And so, after, practicing, I think I got better at least. Anyway, people kept reading my blogs and I kept gaining subscribers on Medium. So I figured, I'm doing something good here. So the hard part is first of all, selecting the subject as well, because many models come out, useful or not, hard to say, right? So, selecting the right subject. And then also, I go through the effort of reading the paper, a good 3-4 times, just to make sure I understand everything makes sense, even making sense out of the mathematical equations. But then, at least I'm explaining them in words afterwards, in the blog itself. So yeah, that's mostly how I do it. And the main challenge of it is, and then, trying to find also a model that is implemented, so that, it's always something I like to do. I want my readers to be able to implement the model and see results with it, not just this is very nice in theory and they say it worked, but there's no way for us to verify that, right? I don't like that. So yeah, that's the main challenge.
Very good. I want to know, what do you think is the big thing coming up in forecasting? What do people should work on, especially the new generations and new people coming into forecasting and they want to grow in this field?
Whoa. Okay. I was not expecting that question. I like it. I don't feel I've been in the field of forecasting long enough to be able to give like a
You're working on
good
foundational
answer.
models, which is,
I know.
right now it's like
Right. For sure, foundation models, I think, are here to stay. I think, the way I describe foundation models right now is like they're the new baseline models. So anyone trying to get into forecasting as a practitioner, I think should get a sense of the fundamentals for sure. but also take a look at foundation models, because again, now we're expecting people to just, let's apply the foundation model first, almost, right? Because it's easy, it's fast and everything, get predictions, and then see, can you build a model from scratch that is better than that? So, that's something people have to learn for sure. And then, I think if you're more, someone working in the field, and trying to like push it forward, there's a few things I would like to see. First one, probably something else than the transformer. I don't know, I'm getting sick of the transformer. It's been like since from 2017, like, okay, let's move beyond that, So I really think there's going to be at some point some other breakthrough architecture that we'll be able to apply in time series as well, and it's going to revolutionize the foundation model landscape. So that's something I would like to see. Explainability for sure, not just to just because we talked about this today, but I think explainability is super important. I want to see more packages doing it, right? I mean, it's nice to be the first ones, the only ones, but it's even better to see that we started something and that everybody else is doing it. So I want to see that. And I also want to see probably something more about causality as well, because again, even in causal inference, again, from my very limited knowledge of the subject, I think the time aspect is also challenging. So if we can, merge those two together, I think we're going to have some very, very powerful stuff there. And the idea always being that you can better explain the world around you, your forecasting task, whatever, you can better explain it, better understand it. And once you do that, then, you optimize. And I think the outcome is always, more positive in that sense. So that's what I would like to see.
Awesome. I like all the topics, and I think they're really important ones to be tackled. There's a lot of work that needs to be done. And in every single of these dimensions that you mentioned. Yeah. I appreciate that. Mariana, did you have a question?
I think now that you're mentioning what you want to see in the future, what are your thoughts on maybe the integration of LLMs with these foundation models, or more like agents? Do you think that is something that we'll see in the future?
Yeah, for sure. So, I mean, as much as we have, vibe coding and everything, I think, those LLMs and those agents, they're going to lower the barrier of entry to forecasting. Good or bad, I'm still not sure. I still think, just like vibe coding in a sense, right? If you're a non-programmer and you're just generating code, you don't know how good your code is. Maybe that, maybe the outcome is going to be good. Most certainly the outcome is going to be bad. LLMs, agents in forecasting. So you add that, natural language layer on top of it to do the forecast themselves. Maybe the forecasts are going to be good. Maybe the forecasts are not going to be good. Are you going to understand your forecast? Hard to say. But I think the integration makes more sense in in interpreting the forecasts or interpreting the models. I think that's where the real potential is. So not necessarily in doing the forecast for you, but then explaining, this is the result, this is the impact that we are seeing. And, now that we have ways of doing explainability, you can have the LLM layer saying, we've seen that this feature impacts the forecast by that much and everything. So I think that's where the integration lies, and or at least, the low-hanging fruit is. Yeah, and I'm curious to see that. I don't think anyone is doing it for now, but I think that would be good. That would be really cool.
Yeah, I think sooner or later we should see something along the line.
Yeah.
And it makes sense to tackle this problem. And I couldn't agree more that we are in a time that actually first principles never have been more important. Just vibe coding without knowing what is going on is not going to the job. So I always tell my students that teaching machine learning unit for first year undergrad student is you have to learn it. It's so tempting to go to ChatGPT or go to Claude and write down this piece of code for me, but you're never going to learn that if you do that. So it's
sure.
a really dangerous thing to do.
Yeah.
So I couldn't emphasize more on first principles at this time.
Yeah, definitely.
Yeah, on that, I want to thank you very much, Marco. It's been a really great conversation talking about new things and important topics in forecasting. And I want to thank, as always, Mariana for organizing this and this interesting conversation, and our audiences listening to these episodes, another episode of Forecasting Impact. I'm hoping that everybody has learned something from this new episodes, and thank you very much.
Thank you.
Thank you so much.
Thank you for taking your time and listening to Forecasting Impact. If you liked this show, please subscribe to our podcast and leave a review. We appreciate you, and we look forward to seeing you at our next episode.